Hello and welcome to video 9 in this third series on expert primary maths teaching, and this video is all about the 6 ways that we deal with divisions when the answers don't work out to be whole numbers. In this video I'm going to be talking about the 3 approximate ways of dealing with answers from divisions when they aren't integers, and integer just means whole numbers, and they are rounding up, rounding down and rounding off. And the 3 exact ways of dealing with answers that aren't whole number answers, and they are leaving a remainder, giving the answer as a fraction, and giving the answer as a decimal number. I'll talk about the kinds of situations when each type of answer is appropriate, and I'll suggest some suitable extension work. So if you don't need this video, here's a link to your next one, which is all about long division, or division by 2-digit numbers. In this video, I'm going to be assuming that you and the child or children you work with are already confident with short division. That's division by numbers between 2 and 9. So if you need the video that explains how to do that, here's a link to it now. When we're looking at decimal answers to divisions, you'll also need to have a good understanding of decimal numbers. So if you need to revise that, here's a link to a suitable video on that. Okay, let's get started by talking about the 3 ways we give whole number answers even when the answer isn't a whole number. The 3 ways of rounding off your answer. In deeply understanding what's going on here, it's really useful to be fluent and confident with the idea that division is usually, in practical context, either sharing fairly or counting groups. And when division is counting groups, we usually end up rounding up or rounding down. Imagine you had 25 eggs and you had boxes that took 6 eggs per box. If you've actually got some egg boxes, which I haven't got here today, it's nice to do this in the classroom. And you don't have to use eggs, you could use Lego bricks or something to represent the eggs. Now, a question might say, how many boxes can you fill? And pretty quickly you can imagine that you're going to be able to fill 4 boxes and there's going to be 1 egg left over. So in basic terms, the answer to the division is 4 remainder 1. But the question might not be asking for that. The question might say, how many boxes can we fill? If you can only sell full boxes, then that extra 1 is irrelevant and your answer is 4. So when you're counting groups and the question is interested in full groups, you round down. You forget about the remainders. They're useless, they don't matter. On the other hand, the question might say, if you want to put all the eggs into boxes, how many boxes do you need? Well, you're going to need 5 boxes, otherwise you can't transport all the eggs. Again, you can demonstrate that pretty quickly, or you can draw it if you haven't got apparatus. So if it's the case where you need containers for all the groups, and classic examples you come across are children are going on a trip and buses take so many children, how many buses do you need? You're thinking about the containers, you're thinking you've got to contain all the objects that you're sharing out. Then you are going to round up. So rounding up and rounding down usually happen in situations where you're sharing your objects, your people, whatever, into groups. And when we're rounding down, we're saying how many full groups have we got, and when we're rounding up, we're saying how many containers do we need, or how many groups will there be altogether if the part group counts as a group. And once we've got the hang of that, then we can move on to larger numbers to stretch a child's imagination, but it's a really good idea to start with small numbers. So for example, you could have 223 eggs to share in boxes, and you could explore what happens. Of course, by this stage, children aren't going to be able to use apparatus or draw what happens. They need to have a good internal picture that they can work with, and you can test whether they have or not by the questions that you ask them. So we could have been considering 223 eggs put into boxes of 6, and we could have thought about how many full boxes or how many boxes do we need to transport them. Now, rounding off tends to come in when we're sharing fairly. This isn't always true, and it's interesting to get children to discuss when it is and isn't true, and I'll come back to that in the extension work. But imagine we had 223 centimetres of ribbon and we were sharing it fairly between 6 students. So we would divide this in the ordinary way. We can't share 200s between 6 people, so we change them into tens. We've got 22 tens, so each person can have 3 tens, and that leaves 4 tens that we can't share, so we get 43 ones, and that gives each person 7, which is 42, so it's remainder 1. So we need to think that that remainder 1 is going to be less than half. Half would be remainder 3. So if we round that to the nearest centimetre, each person is getting 37 centimetres. And there are circumstances in which you only want the accuracy to the nearest centimetre. So there are your 3 rounding situations. So what about if you want an exact answer? Well, your first exact answer is just to leave a remainder, and that's very intuitive and instinctive, and there are lots of situations where there's the right thing to do. So you might be trying to put children into groups. You've got 33 children, you want to put them into groups of 4, and you want to know what happens. And you'll get 8 groups of 4 and 1 child left over. 8 remainder 1 is the answer that you're looking for. And answers with remainders can come in counting group situations and sharing fairly situations. But if you're focusing on sharing fairly, you also sometimes get answers with fractions and answers with decimals. So imagine we wanted an exact answer to a ribbon sharing problem. We've got 67 centimetres of ribbon, we're sharing it fairly between 5 people. Exactly how much ribbon does each person get? So our 6 tens we can share between 5 people. Each person gets 1 10. We've got 1 to break up. Our 17 ones, each person gets 3. We could say remainder 2, but that doesn't reflect what happens in that situation. We would actually cut the ribbon. How much does each person get? Well, the first way to do it is to continue with decimal numbers. If we just extend this, we can now exchange our 2 remaining ones into tenths. We could do this with place value counters. Exchange 2 for tenths, we're going to get 20 tenths. And 20, if we're sharing them between 5 people, each person gets 4 tenths. And we are done. 13.4 is an exact answer. Now at this stage, age 9 to 11, the number we're dividing by is probably going to be only 2, 5, 4, which can lead to quarters, so 0.25 or 0.75, so we may have to exchange tenths for 100ths, or at a stretch, eighths, where we have to exchange hundredths for thousandths. I'm going to do a video on thousandths soon, so I wouldn't introduce that yet, but children might go for it and enjoy it, and in fact it's one way of accessing thousandths. We wouldn't be dividing by 3, 6, 7 and 9 or larger numbers that lead to recurring decimal answers. That comes later. So our first exact answer was 13 remainder 2. Our second exact answer to this division is 13.4. What about if we wanted it as a fraction? Let's just take this back a bit. So we've got to this stage and we've got 2 left, 2 centimetres of ribbon left that we have not divided. There are 2 centimetres of ribbon that we haven't divided, and the easiest way to imagine this is to cut each into 5 parts. Always cut each of the things you've got left into this many parts. And then we have got 10 fifths here, and we can share those fairly, and the answer is that when we split those into 5 equal parts, each person gets 2 fifths. If you follow this method exactly, you are always sharing the number of things you've got left into this many parts. So the bottom number, the denominator of your fraction, is going to be this number. And from each thing you get one part. So the top number of your fraction is going to be your remainder. So if it's remainder 2 and you're dividing by 5, you get 2/5. If it's remainder 3 and you're dividing by 7, you get 3/7. If it's remainder 5 and you're dividing by 9, you get 5/9, and so on. If you do lots of these carefully, you will see that pattern. You'll come to appreciate how it works and why it is so easy once you've seen it. I did create a video a few months ago that looks just at this, at getting fractions like these when you're dividing 2 by 5, that it is always 2/5. So if you'd like to look at that in more depth, here's a link to that video now. So you've 3 ways of getting exact answers. One is to write the answer with a remainder. The other is to extend your division into the decimal places to write your answer as a decimal. And at this stage, we're only doing that when we're dividing by 2, 4, 5, and 8. And the third way is to write a fractional answer. And you can do that when you're dividing by any number. As extension work for this, I would challenge your children to come up with 12 imaginable or real-life division problems, 6 of which are counting groups problems and 6 of which are sharing fairly problems. And for each group of 6, you want one problem which is best answered with each of the 6 ways of dealing with non-whole number answers. And they can do displays on that, and they can test their problems on each other, and they can rate each other's problems. And that's going to generate some really powerful discussions. It may not be possible to find all 12. You can set it as a challenge to see how many they can do. Let them go for the easy ones first rather than working through them in systematic order. And if they want to do display work of their problems, that would be fantastic. This will really help them deeply think about everything that we've just been talking about. So your takeaways from this video are that there are 6 ways of dealing with divisions when they don't give whole number answers. 3 of them are approximate. They are rounding up, rounding down, and rounding off. And 3 of them are exact. They are leaving a remainder, calculating the answer as a decimal, and calculating the answer as a fraction. Some of them tend to happen when you're dividing by counting groups. Some of them tend to happen when you're dividing by sharing fairly, and it is really interesting to try and come up with examples of each type because it consolidates everything we've been doing so far in division in primary maths. I hope you found that useful. If you have any questions, please write them in the comments. If you like the video and think it might be useful for anyone else you know, please share it. And I hope to see you again soon for the next video, which is all about division by 2-digit numbers, and we'll cover short division and the different types of long division. Have a great day. Bye for now.